Hi everyone. So in this video, I'm going to be talking about different problems that we have that involves like momentum, conservation of momentum, kinetic energy, conservation of kinetic energy, and things like that. So I'll start with basically momentum and things that like recoil speed and things like that. So we can have a problem where it says there is a gun and a bullet that are there at rest, and then the bullet's mass is 5 grams, and the mass of the gun is about 3 kilograms. After the bullet is fired from the gun, so after it's fired, the bullet's velocity becomes 500 meters per second. What is the recoil's speed? Okay, so basically we're solving for, we know the mass of the bullet, we know after it's fired, the velocity of the bullet is 500 meters per second square, mass of the gun, and we are solving for the recoil speed of the gun. So this is how the whole thing looks like. Before the bullet is fired, the bullet is inside the gun and they are both sitting at rest at velocity of 0. Afterwards, what happens is that the bullet gets fired with a speed of 500 meters per second, and as a consequence of conservation of momentum, the gun recoils. And we are wondering what that velocity would be if its mass is 3 kilograms. So conservation of momentum tells us that P before is P after. The momentum of all the ingredients that we have before should be equal to the momentum of all the ingredients afterwards. Before, everything was at rest, right? Everything was at rest, and so its momentum, mass times 0 gives you 0, plus this portion of the question this portion of the problem that was like 3 kilograms gun was sitting at rest, so the whole momentum becomes 0 before. And now after the collision, what happens is that the bullet that was 5 grams, so 5 divided by 1,000 to make it a kilogram, times 500 meters per second, because momentum is mass times velocity. So momentum of the bullet plus momentum of the gun, momentum of all the ingredients that we have added up. So the gun is 3 kilograms and the velocity of the gun is now what we are solving for, right? So when we do this, we see, well, let's do the math together. 0 equals 25, 2.5 actually, plus 3v, and I need to bring this to the other side. So basically I'm subtracting 2.5 from both sides, so I'm having this equals 3v, and then 2.5 divided by 3 gives me velocity of minus 0.83 meters per second. This negative here shows that the velocity of recoil velocity is actually in the opposite direction than the velocity compared to the velocity of the bullet itself. See, the arrows are in opposite directions, and this is plus 500 meters per second. Sure, this turns out to be 0.083 and like basically negative 0.083. So basically that's why it's hence it's a recoil speed. So this is essentially how recoil problems are done, and this is how we do them. Other questions could be about let's say about having having two billiard balls, a head-on collision between two billiard balls. I can say the one billiard ball has mass of, let's say, 500 grams, and it goes by 2 meters per second. After the the other billiard ball has a mass of 600 grams, and this guy goes by 3 meters per second. And as you see, because it goes to the left, I need to include the velocity and with a negative number. The reason is because momentum is a vector quantity, so you need to include the velocity with its direction in order to respect the vectorness of momentum. So before the collision, before this head-on collision, these two, the momentum of all the ingredients in the system of two billiard balls is in this way, so in this order. So M times V plus M times minus 3, and that gives you total momentum of all the ingredients in your system before the collision, before they hit each other, right? So when you do this, you get 1 kilogram meters per second for this one, minus, so that goes, that divided by 2 gives me 3, divided by 2 gives me 5. Okay, so that gives you actually, yeah, that would give you 1.8, but negative 1.8. So overall, you are going to be having minus 0.8 kilogram meters per second for your momentum before the head-on collision. And we know for all the collision, if it's elastic or inelastic, all collisions, no matter what type they are, we always have conservation of momentum. So we know after they hit each other and after they go away from get away from each other, the total momentum of the system of these two balls essentially is this number once again. So this is how we do the conservation of momentum problems. We need to respect the fact that conservation of momentum means that the number for momentum that we get for a system before and after the collision, they stay the same. So which means that total before and after it stays the same, which means that the total ingredients, like now we are having 2 billiard balls. So total number of momentum for each and every one, when you add them up and you get a total, that number, whatever it is, now in this case was like minus 0.8, that number stays the same no matter what happens in the system. Okay, so this is that. There is another type of momentum problems that essentially it's, it's impact problem. Impact problems are dealing with delta P. Delta P is P2 minus P1. So I want, and which is obviously force times the time during which force is exerted. I want everyone to understand that this is change in momentum, which is this minus that. For collision problems that we have P before equals P after, you need to write down total momentum of all the ingredients before and equate that number with the total momentum of all the ingredients that we have in the question afterwards. Total means adding things up. Now, because momentum is can come with a negative sign because of its vector nature. Sometimes there is this negative sign because of the velocity. Nonetheless, you're adding these numbers. Whereas delta P, which relates to change in momentum, comes with a negative sign inside the formula. I want everyone to understand the difference between these two scenarios. I'll talk about more problems in the next video. Bye-bye.